Welcome, geometry students. Today we're going to learn about how to use properties of rhombuses, rectangles, and squares in order to solve problems. So the first thing we need to discuss is how these different quadrilaterals relate to one another. So we kind of have a hierarchy here, where as we start at the top, we're the least specific, and as we go down, we're getting more specific. So we're adding more details to our picture here. So let's look at this graphic organizer. We start with quadrilaterals at the top. And the main thing we need to know in order for a shape to be a quadrilateral is it's a polygon with four sides. So a four-sided polygon. Okay, so that is our least specific information. But as we move down, now we have a parallelogram. In addition to knowing that it has four sides, we also need to know that both pairs of opposite sides are congruent. I'm going to move mine over just a minute here. Both pairs of opposite sides are congruent and parallel. We also know, if we think about a parallelogram, that opposite angles are congruent, consecutive angles are supplementary, and finally the diagonals bisect each other. So at this point, we should know all of those facts about a parallelogram. If we don't, that's something that we need to study. So we're going to move on to the next shapes today. We're going to be looking at rhombus, and we're going to be looking at a rectangle. So here's what we need to think about. So a rhombus, a rectangle, and finally, we're also going to be looking at a square. So when we look at rhombus, rectangle, and squares, these are all four-sided figures. So therefore, they are all examples of quadrilaterals. So they hold this trait that we see up at the top. They are also going to be examples of a parallelogram. So all of the traits that we just listed about a parallelogram apply to a rhombus, apply to a rectangle, and apply to a square. What we're going to do now, though, is take those traits and add more to them. So rather than thinking about the fact that a rhombus is separate from a parallelogram, we're going to think of it as a parallelogram, but with one additional detail. We're going to think about it as it has all of the traits of a parallelogram, but it also has four equal sides. So not only are opposite sides congruent, but all four sides are congruent. So I think of a rhombus as a square that got pushed over. So we have a rhombus with four equal sides. A rectangle now is a parallelogram. So everything we just stated about a parallelogram is still true. In addition to that, it has four right angles. And then finally we have the super shape, which is a square. A square has all traits of a parallelogram. It also has all of the traits of a rhombus and all of the traits of a rectangle. So essentially it's the super shape because it has all of the traits of everything above. So essentially when I look at this, I'm going to draw in some arrows. A square is also a rhombus, and it's also a rectangle. So every single square holds the traits of a rhombus, and it holds the traits of a rectangle. Well, since every single rhombus holds the traits of a parallelogram, and every single rectangle holds the traits of a parallelogram, that means that a square is also a parallelogram. So essentially, what we have is we know, if you could make a note over here, a rhombus is a parallelogram. Likewise, a rectangle is a parallelogram. Now, as I mentioned before, we're getting more and more specific as we go down. So anything below something else above in the graphic organizer, anything below is going to have the traits of something above it. But the vice versa is not always true. So we're saying a square is also a rectangle. But does that mean every single rectangle? So looking at this, our hierarchy tells us that we have the least specific being quadrilaterals, then parallelograms, then rhombus and rectangle, and finally squares is our most specific shape, which is the super shape that has all the traits of the shapes above. All right, let's look at example 1. It says to use the properties of parallelograms. It tells us that RSTV is any rhombus. We need to decide whether the statement is always or sometimes true. Well, I would not begin this without a picture. So let's draw a picture of a rhombus. We need to know that a rhombus is a parallelogram, so opposite sides parallel, opposite sides congruent, opposite angles congruent, and so forth. All of those traits we know and have memorized about a parallelogram are going to apply to this rhombus. But in addition to that, we just learned that it also has 4 equal sides. So that's the new trait that we need to know about any rhombus. Now we look at this, it says angle S and angle V are congruent. Well, let's label our picture. We start at one vertex, any vertex is fine, and then we move around. So R, S, T, and V is how that would look. And it says, is angle S congruent to angle V always or sometimes? Well, angle S is opposite angle V in the parallelogram. Remember, a rhombus is still a parallelogram. So are opposite angles in a parallelogram sometimes true to be congruent or always congruent? Well, if we think about one of the traits of a parallelogram, the opposite angles are always congruent. So this is always true because the opposite angles of a parallelogram are always congruent. Now you might be thinking, but this isn't a parallelogram, it's a rhombus. Keep in mind that a rhombus is just a specific type of parallelogram. So a rhombus is still a parallelogram, as well as a rectangle and also a square. Those are all examples of parallelograms. All right, well, we're going to use the same picture here. And now it says, is angle T always or sometimes congruent to angle V? Well, angle T is here and angle V is here. Those are not opposite angles, they're consecutive angles. So what we want to consider is what's true about consecutive angles in a parallelogram. Well, the fact is that they are always supplementary. But when would they be congruent? Because this is saying when are they congruent? The only time that this would be true is if they're supplementary and congruent. So the only option for that would be if this was 2 angles that were right angles. So if that was the case, this would no longer be a rhombus. It would have to be a rhombus with one more specific detail, and that would be the right angles. So this would actually make it a rhombus that's also a square. So this is sometimes true, but only when the rhombus is a square. Keep in mind, a square is a more particular type of rhombus. So a square is still a rhombus, it just has the right angle piece that a rhombus does not require. So this is going to be true, but only when the rhombus is also a square. Example 2 says to classify the quadrilateral, and we're going to explain the reasoning. Well, we know it has 4 equal sides. So a 4 equal-sided quadrilateral could be a square or it could be a rhombus. The reason why this particular figure can't be a square is we don't have right angles. So the most specific name for this quadrilateral is a rhombus. because it has 4 equal sides, but no right angles. If we knew that that angle was a right angle, then we could safely say that this was a square, but we don't. Okay, you want to pay really close attention to the diagonals of the different parallelograms we're learning about, because they're going to play an important role in the solving problems that we're going to be doing. So let's talk about the diagonals of a rhombus. The diagonals of a rhombus is basically telling us that a parallelogram is a rhombus if and only if its diagonals are perpendicular. So go ahead and draw a picture below that. So this parallelogram is only going to be a rhombus when the diagonals are perpendicular to one another. Now let's talk about another trait. A parallelogram, whoops, sorry about that, is a rhombus if and only if each diagonal bisects, if you would please cross out the word R and put bisects both pairs of opposite angles. So if we draw another rhombus, a parallelogram with 4 equal sides, looks something like this. Okay, so there's our rhombus. If it's a rhombus, then we know that when we draw on the diagonals, that the diagonals will bisect both pairs of opposite sides. So let's think about this for a minute. I'm sorry, I said both pairs of opposite sides. I meant to say both pairs of opposite angles. So these diagonals are going to bisect the angles. So we think about the fact that the opposite angles in all parallelograms are congruent, then we know that those 2 pairs of angles are congruent. But now what we're saying is that the angles are being bisected. So what that means is that this angle in green is being cut in half. So that's bisecting the angle. Just like we bisect segments, we can also bisect angles. So angle 1 and angle 2 would be cut into 2 equal parts. Likewise, 3 and 4. So really, since the original angle was congruent, we'll call it A, to angle C, then when we bisect it, all of the parts are going to be congruent. So angle 1 is going to be congruent to angle 2, is going to be congruent to angle 3, is going to be congruent to angle 4. The same is true at vertex B and D. Since those 2 angles were congruent to begin because they're opposite angles in a parallelogram, angle 5 and angle 6 are congruent to angles 7 and 8. So we're bisecting those larger angles and cutting them into 2 equal parts, so therefore those are going to be true. Now this is only true for a rhombus. So if we look at what we just discussed, we said that a rhombus has perpendicular diagonals and it bisects the angles. So if this is true for a rhombus, there's another particular shape that holds the traits of a rhombus. Can you think of what it is? Hopefully you're thinking a square. So remember I said this square is a super shape because it holds all of the traits of all the parallelograms. So a square would also have the traits that we just mentioned here about a rhombus. Okay, let's talk about the diagonals of a rectangle. So now we're sharing information about a rectangle. A parallelogram is a rectangle if and only if its diagonals are congruent. So if we have a rectangle, it's a parallelogram with right angles. If we have a rectangle, then we know the diagonals are going to be congruent to each other. So EFGH means that FH is congruent to EG. Now, let's talk about this for a minute. We've yet to discuss what we know about the diagonals of all parallelograms. So if you remember back in the very beginning slide, I shared with you the traits of a parallelogram. One of them was that the diagonals bisect each other. So that's still happening here. But if we think about it, if we simply knew this was a parallelogram, we would know that that is a midpoint. So those two would be equal segments. And we would know that those two would be equal segments. But since this is not just a parallelogram, it's more specifically a rectangle, it's going to hold the traits that I just mentioned, that the diagonals are going to bisect one another. But we also know that the diagonals started being congruent. So let's just say the length of HF is 10 units. If I cut that into two equal parts, each of those would be 5 units. And then if we know that this is a rectangle, since the diagonals are congruent, that would mean that EG is also 10 units. So really, these would each be 5 units as well. So now, instead of just saying that each diagonal is bisected, it's bisected, but they also began congruent. So all 4 of these parts to the midpoint would be equal to one another in a rectangle. Now, since a square is also a more specific type of a rectangle, this also applies in a square. Example 3 says to list the properties of the special parallelograms. We need to sketch a rectangle EFGH. Go ahead and do that now. And we know it's a rectangle. So since this is a rectangle, we need to list everything we know about it. And there's going to be a lot, so be prepared to list everything. Now I'm going to go back to the hierarchy that we drew in the very beginning of our notes. If you do that, the least specific type of shape is that this is a quadrilateral. Now we could go on to say that this is a polygon, or we could say that kind of information, which is fine. So a polygon. It's also a quadrilateral because it has 4 sides. We can also go on to say that it's a parallelogram. Now, because it's a parallelogram, we need to list everything we know about any parallelogram. So we're going to be specific to the picture here. So parallelograms' opposite sides are congruent. So we know EF is congruent to GH. We also know EH is congruent to FG. Now another fact of a parallelogram is that opposite sides are parallel. So EF is parallel to GH and EH is parallel to FG. In addition, we know opposite angles are congruent. So angle E is congruent to angle G, but we also know that this is a rectangle. So they're all going to be congruent to one another, and those all equal 90 degrees. We can also go on to say that the consecutive angles are supplementary. So angle E and angle F and angle G, angle G and angle H and angle E are supplementary angles. Now, what we have yet to discuss is the diagonals. So we need to know that in any parallelogram, the diagonals bisect each other. So I'm going to put a midpoint here. So we know that HF bisects EG, There's the diagonals bisecting. But we also know that in this case, since it's a rectangle, not just any old parallelogram, that those diagonals are going to be congruent. Therefore, since the diagonals are congruent and they're bisected, we can say that EM is congruent to MG, is congruent to MF, and is congruent to HM. So look this over and see if there's anything I've forgotten. I think we've included everything that's important to know, but the key is you may have thought initially you would only share a couple of things about a rectangle, maybe just that it has 4 right angles. But as you can see, we know a lot more about any rectangle than just that it has 4 right angles. So you're just going to use that hierarchy every time and add your information from the least specific shape to the most specific. Doing that is going to give you the best approach because it'll allow you to hopefully not miss any of the traits. All right, this is the last visual which shares with you the different properties of the parallelograms. Again, outer is least specific. And then as we get in, think of your Venn diagram that you use in your English class, for example. So anything where they overlap means that that's what's in common. So a square holds the traits of a rhombus, of a rectangle, and a parallelogram. Whereas a rhombus holds the traits of a parallelogram because it's within that, but it does not hold the traits of a square. Now, keep in mind, some of the rhombuses do overlap. So some of the rhombuses will also hold the traits of the square, but not all. Similarly, we can say the same for rectangles. Some of the rectangles go into the square grouping, but that's only when the rectangle has 4 equal sides. So not all rectangles are squares, but all squares are rectangles. That's a little confusing at first, I know, but we'll work with that more. Go ahead and try your You Try Nows and bring questions with you tomorrow. Have a good day.